Good evening, students. Today in coordination compounds I want to explain regarding isomerism. Uh, if you understand isomerism, I want to explain some questions, question and answers. From that you can learn easily isomerism. First of all, we take first question. Which of the following complex do not exhibit optical isomerism? Which of the complex do not exhibit optical isomerism? This is the one of the question. If you take, I want to give example. First one is platinum, bromine, chlorine, iodine, NO2, C2H5N, and ammonia. This is the hexadentate octahedral complex. Okay. Next option B, we take cis cobalt ethylene diamine dichloride. Okay. If you take third option, cobalt ethylene diamine ammonium diammonium dichloride. If you take another question, chromium tetraammonium dichloride. If you take these four options, what is the question? Which of the complex do not exhibit optical isomerism? If you can take these four options, in four options, which one does not show optical isomerism? How to? First of all, we have to discuss about which one will show. Then we eliminate which one does not show. This is we have to explain. First of all, you take first option. In first option, all platinum, bromo, chloro, iodo, nitro. This is pyridine. This is ammonia. These 6 ligands are 6 different ligands. First, you have to consider optical isomerism. What is optical isomerism? So if you take isomerism, one is geometrical, next one is optical. These stereoisomers. If you take stereoisomers, in stereoisomers we have to consider both geometrical isomerism as well as optical isomerism. If you consider these two isomerisms, combinedly call it as a stereoisomers. If you take another one is structural isomers. Structural isomerism. What is structural isomerism? Structural isomerism means, if you in case of coordination compound, structural isomerisms are different types. One is linkages isomerism, next ambidentate, next ionization isomerism. These are the structural isomers. If you consider coordination compounds, we have to see structural isomerism, stereoisomerism. Structural isomerism is linkage isomerism, ambidentate, ionization. These are etc. If you take stereoisomers, we have to consider geometrical and optical isomerism. In this question, they will ask only optical isomerism. We have to consider this optical isomerism only. We have to see. We don't consider geometrical and structural isomerism. If you take option A, 6 different types of ligands are attached to the central metal atom. That's why it will show optical isomerism. It will definitely show optical isomerism. It does not having plane of symmetry. It does not show any symmetry. That's why it is called show definitely optical isomerism. This option we have to eliminate. We have to which one does not show optical isomerism, then we have to tick as a right mark. First one you have to eliminate. Next we have to take second option, cis cobalt ethylene diamine dichloride plus. How to consider this one? First you have to see central metal atom is cobalt, ethylene diamine, nitrogen. This is the bidentate ligand. These two chlorines are cis position. If you take another one, this is the one of the type cis type. Cis cobalt ethylene diamine dichloride. This will show any plane of symmetry? No, it will not show any plane of symmetry. If you take vertically, it will not show, it will different. If you take horizontally, it will different. In both cases, in different types, it does not show any plane of symmetry. That's why it is optically active. Optically active means it will show optical isomerism. This you have to eliminate. Next we have to consider second option, cobalt diamine, cobalt diamine diammonium and dichloride. If you consider this one, this is the two different types. One is cis form. These two nitrogens are we have to take cis form. All are in cis position. Then we have to take one more. All are in trans form. This, if you take consider two ammonias and two chlorines are in cis form, then we have to consider this is also having no plane of symmetry. It will show optically active. If you take one more form, it doesn't mention any cis or trans. This is having two types of isomerisms. One is cis form, another one is trans form. Next we have to consider take trans form. This is how to eliminate. Cis form is optically active. We have to consider trans form. To take cobalt diamine, to take two chlorines are in trans, then ammonias. In trans form, this is trans form. In trans form, it will show plane of symmetry. It will completely divides two halves. That's why it is optically inactive. Inactive means it does not show optical isomerism. Cis form doesn't, trans form does not show optical isomerism, but cis form will show optical isomerism. But it does not mention any cis or trans like that. That's why we don't fix the answer from this only. We have to consider one more option. To take D, chromium tetraammonium dichloride. Tetraammonium dichloride. If you consider this one, tetraammonium dichloride, this will show plane of symmetry. It will completely show plane of symmetry. If you take tetraammonium dichloride, it will show plane of symmetry, because if you take this one plane, it will optically inactive in case of cis form also. If you consider trans form, also, both two chlorines are at opposite side, 4 ammonias is there. This is trans form. In cis form is optically inactive. Trans form also having plane of symmetry. This is also optically inactive. This is optically inactive. In both forms it will show optically inactive, but in this case it will show only transform will be optically inactive, remaining all are optically active. That's why we have to take answer this one. It will not consider this one. Our option D is the right, which does not show any optical isomerism. Remaining all are optically active. First, we have to discuss in this question mainly which of the following complex does not exhibit optical isomerism. They have given four options, four different optical complexes. One is platinum, bromine, chlorine, iodine, nitrogen, pyridine, and ammonia. Cis, cobalt, ethylene, diamine, dichloride, cobalt, ethylenium, diamine, dichloride, chromium, tetraammonium, dichloride. These four options they have given. They are asking optical isomerism. First of all, we have to know what is optical isomerism. Generally, isomerisms are different types, two types. One is structural isomerism, another one is stereoisomerism. In structural isomerism, different linkages. They depends upon ligands. Vary linkages, ambidentate, ionization, etc. In case of stereoisomerism, also two types. One is geometrical isomerism, one is optical isomerism. In that, they are asking only optical isomerism. If you take optical isomerism, first one will show optical isomerism because the 6 different ligands are attached to the central metal atom. It will not show any plane of symmetry. That's why it will definitely exhibit the optical isomerism. This option is out element. Next, we have to consider cis ethylene cobalt ethylene diamine dichloride. This will cis form, it will have no plane of symmetry. That's why definitely this is also exhibit optical isomerism. If you consider cobalt ethylene ammonia dichloride, in this we have to already discuss. Transform will show optically active. Cis form does not show optical isomerism. They are not clearly mentioned. You have to doubt. That's why you have to eliminate this one. In case chromium tetraammonium dichloride, we have discussed in this both forms, cis and transform, both are optically inactive. That's why this option is the correct one. Sorry, just